Hello everyone. So this is Vishu Chaudhary from Infinity Vision. So today I will discuss the detailed solution of JEE Main 2024, 1st of February, Shift 1 chemistry paper. So let us see the paper. So here is question number 1. If one strand of a DNA has the sequence, you are given a particular sequence of the bases in complementary strand is, now we know that in DNA, we have adenine base, which pairs with thymine base via 2 hydrogen bonds. And we have cytosine base, which pairs with guanine base via 3 hydrogen bonds. So if we see this, so what is the sequence of the bases in complementary strand? So this will be adenine pairs with thymine. So it starts with T. And here we get the second option as the answer, right? Adenine pairs with thymine, then thymine pairs with adenine, guanine with cytosine, and so on and so forth. All right? I hope the question is clear to you. Let us move to the next question. Here's the next question. It is a statement type question. Let us see. Given below are two statements. One is labeled as assertion and the other is labeled as reason. So assertion is haloalkanes react with KCN to form alkyl cyanides as the main product, while with AgCN form isocyanide as the main product. And the reason for this they have given is KCN and AgCN both are highly ionic compounds. All right. First of all, we know KCN is an ionic compound and AgCN is a covalent compound. So this reason is definitely wrong. This is incorrect because AgCN being covalent in nature. Now, coming to the assertion, haloalkanes react with KCN. Yes, because we have this cyanide ion, right? It acts as a nucleophile and it is an ambident nucleophile because it can attack from carbon as well as nitrogen and carbon being more facile. Now, so here in the presence of this KCN, we definitely get RCN, that is alkyl cyanides. And with AgCN, we know it is a covalent compound, so we are left with just the nitrogen end as the nucleophilic end, right? And what do we get? We get RNC, that is alkyl isocyanide as a major product in the case of, right? In the case of AgCN. I hope this is clear to you. So we have A is correct, but the reason is wrong. So A is correct and R is not correct. First is the right answer. I hope the question is clear to you. Let us move to the next question. Here is question number 3. In acidic medium, potassium dichromate shows oxidizing action as represented in the half reaction. And you are supposed to give the values of X, Y, and Z respectively. All right. So let us see. We have dichromate ion. The oxidation state of chromium here is +6. We know in acidic medium it changes to chromium +3, right? So here are 2 chromium, so I can write 2 over here. How many electrons are involved? 6 electrons, right? So I can write 6 electrons over here. Now, the next step is to balance the oxygen atoms by putting equal number of water molecules. So here we have 7 oxygen, so I'll put 7 H2O molecules over here, right? And now the need to balance the H by putting the equal number of H plus ions. So here we have 14H, so I will put 14H positive over here. So if I go by this, we have X value to be 14, Y value to be 6, and then we have A value, which is 7. So A value is, 2, and then we have Z value, which is 7. So let us see the option. We have 14, right? Then we have 6 for this value. Yes, 4 is the right answer. We have 14 for X. X is that means that much number of H plus ions. For Y, 6 electrons are involved, so we have put 6. And then there is Z. So Z is the number of water molecules, which is 7. And A is Cr3 plus ion. I hope the question is clear to you. Let us move to the next question. Okay, the fourth question is, which of the following reactions are disproportionation reactions? So disproportionation reactions, as we know, where one of the species gets oxidized as well as reduced, that means self-oxidation and reduction. So let us see the A part. We know that cuprous ion is unstable in aqueous solution, right? And it disproportionates into copper 2 plus and copper, where it is 0. In the second, in the B option, they have given, this is potassium manganate. We know potassium manganate, MnO42 minus in the acidic medium. It disproportionates into permanganate ion, that is MnO4 minus, and MnO2, that is, here it is in +4, here it is in +7, and here it is in +6. So this is also an example of disproportionation reaction. So A is correct, B is correct. In C, we have potassium permanganate. Now, manganese is already in the highest oxidation state, so obviously it won't undergo disproportionation reaction. This is wrong. And in D, we have, now D is also not an example of disproportionation reaction because the same species is not getting oxidized as well as reduced. So, as per the question, we have A and B as the correct answers. So, let us put first is the right answer, A and B, which both of these, in both of these reactions are the examples of disproportionation reaction. Let us move to the next question. In case of isoelectronic species which have the same number of electrons, right? The size of F minus, neon, and Na plus is affected by, okay, principal quantum number, no, because if we see the electronic configuration of all of them, that is 1s2, 2s2, and 2p6. This is the electronic configuration. So are these affected by principal quantum number? No, this is wrong. None of the factors because their size is same? No, their size is different. How can their size be same? We have the same number of electrons, but the nuclear charge is different, right? The nuclear charge is different. So electron-electron interaction in the outer orbitals? No, we have the same number of electrons. This is also incorrect. This is also incorrect. And nuclear charge, the size of these isoelectronic species is affected by, yes, the nuclear charge. The fourth is the right answer. Like I said, they have the same number of electrons, but the nuclear charge is different, right? I hope this is clear. Okay, let us move to the next question. According to the wave-particle duality of matter by de Broglie, which of the following graph plot presents most appropriate relationship between wavelength of electron and momentum of electron? So we know, according to de Broglie, wave-particle duality principle, we have lambda is directly, it is inversely proportional to the momentum, right? And in order to remove this proportionality sign, we write h upon p, where h is your Planck's constant. Now they are asking you the relationship between lambda and p in terms of a graph. So I can write lambda into momentum, that is h, or that is constant. That is constant. It is similar to PV is equal to constant type of equation. So what do we get? We have when xy is constant, what is the nature of the curve? That is rectangular hyperbola. So let us see. So lambda and momentum, yes, first is the right answer. So when xy is equal to constant, just like PV is equal to constant, we get a rectangular hyperbola as the nature of the curve. I hope the question is clear to you. Let us move to the next question. Given below are two statements. A solution of, this is the aqua complex of nickel, is green in color, and a solution of NiCNO4 2 minus is colorless. All right. Now, Ni here, nickel is in +2 oxidation state. If you see the electronic configuration, that is argon 3d8, right? And water being a weak field ligand, we have the, two unpaired electrons over here. So there is a possibility of DD transition, right? DD transition. And what happens because of that? The red color is absorbed, and the complementary green color is seen. So yes, a solution of aqua complex of nickel 2 plus is green in color. Yes, it is colored. Why? Due to DD transition. due to DD transition. And a solution of this complex is colorless, yes, because nickel here is +2 oxidation state. So again, it is argon 3D8, but this time cyanide being a strong field ligand, it pair up the electrons, and hence there is no unpaired electron in this complex. The complex is diamagnetic in nature. The complex is diamagnetic, and hence it is colorless. So both the statements are true. So both statement 1 and statement 2 are correct. So second is the right answer. Both these statements are correct. Okay. So I hope the question is clear to you. Let us move to the next question. Again, the statement type question. Given below are two statements. So assertion is pH3 has lower boiling point than NH3. Reason is, in liquid state, NH3 molecules are associated through van der Waals forces, but pH3 molecules are associated through hydrogen bonding. All right. Now, let us see the assertion. pH3 has lower boiling point than NH3. Absolutely correct. NH3 has higher boiling point. Now, what is the reason? Because NH3 molecules are associated through van der Waals forces? No, they are associated via hydrogen bonds. Hydrogen bonds. And unlike NH3, pH3 molecules are not associated via hydrogen bonding, right? So the reason is incorrect. We know that the hydrogen attached to fluorine, oxygen, nitrogen is capable of undergoing hydrogen bonds, or is capable of showing hydrogen bond, right? And hydrogen bonds is an example of a strong dipole-dipole interaction, which is the reason for the higher boiling point in case of NH3. So the assertion is correct. Yes, pH3 has lower boiling point, but the reason is incorrect. Okay, so A is correct, but R is not correct. So fourth is the right answer. I hope the question is clear to you. Let us move to the next question. Okay, identify A and B in the following sequence of reactions. So we start with toluene. And what is the reagent? We perform chlorination in the presence of light, right? What is this reaction? This is, benzylic substitution. This is benzylic substitution, right? So what do we get? We get something of this sort, CHCl2, right? This is benzyl chloride. Now depends how many times we are performing the chlorination. So since we don't have any options with mono substitution, so let's try with the di substitution. What do we get? Benzyl chloride. And when it reacts with water, what happens? The Cl are replaced by OH, right? The Cl are replaced by OH. We know that two OH on the same carbon, that's unstable. So there will be a removal of water molecule, right? Sorry. There will be a removal of water molecule. And what we end up getting is benzaldehyde. Yeah, what we end up getting is benzaldehyde. So this is one of the methods of preparation of benzaldehyde from toluene. So let us see. Here we have benzyl chloride, and here we have benzaldehyde. So second is the right answer. I hope the question is clear. Now, if we perform 3 times chlorination, then we end up getting benzoic acid, right? Okay, so let us move to the next question. Statement 1, aminobenzene and aniline are same organic compounds. Yes. Very simple. Aminobenzene and aniline, they are the same organic compounds. Absolutely correct. Aminobenzene and aniline are different organic compounds? No, they are same organic compounds. So aniline and aminobenzene, it is the same. So statement 1 is correct, but statement 2 is incorrect. All right? Quite a simple question. Let us move to the next question. All right. Which of the following complex is homolaptic? Homolaptic means that all the ligands are same. All the ligands attached all the ligands attached are same. So going by the definition, first is the right answer. Yes, other three are the examples of heteroleptic complexes. All right, let us move to the next question. Which of the following compound will most easily be attacked by an electrophile? All right. For an electrophile, there should be an activating group attached to the benzene ring, which would increase the electron density, right? So if we see, this is your plus M group, right? This is also electron releasing in nature, but via, we can say, plus H. Then this is, here we have minus I as the dominating effect, and this is simple benzene. So obviously fourth is the right answer. Why? Because OH, because of the availability of the lone pair on O, it acts as a plus M group. That means highly electron releasing group. All right. So which will be most easily attacked by an electrophile? The answer is fourth, right? Because OH is highly a strong activating group. All right. Let us move to the next question. Ionic reactions with organic compounds proceed through homolytic bond cleavage, heterolytic bond cleavage, free radical formation, primary free radical, secondary free radical. Now, I think this is one of the easiest questions in this paper. Ionic reactions with organic compounds proceed through heterolytic bond cleavage. Why? Because upon heterolysis, what do we get? We get ions. Right? Cations and anions. So it leads to the formation of ions or charged species. So ionic reactions are, they proceed via heterolytic bond cleavage. That is B only. Very simple. I hope the question is clear to you. Let us move to the next question. Arrange the bonds in order of increasing ionic character. For ionic character, what do we need to check? The polarity. The polarity or the electronegativity difference. Greater the difference, more will be the ionic character in the molecule. So let us see. And we should be knowing that ionic character is inversely proportional to size of ion. Right? Is inversely proportional to size of ion. So going by these factors, N2 is the least, yes, because it is covalent molecule. The electronegativity difference is 0, right? Okay, and LIF being the most, yes, because we know fluorine is the most electronegative element in the periodic table, followed by K2O, yes, absolutely correct. Why? We also know that oxygen is less electronegative than fluorine. Now, between SO2 and this interhalogen compound ClF3, we know that fluorine is highly electronegative, so which makes ClF3 more polar than SO2, right? And we should also be knowing their shape. SO2 being a bent molecule, ClF3 is having the T shape, right? So third is the right answer. Yes. So whenever there is a question based upon ionic character, just go for electronegativity difference, go for polarity. More polar the bond is, will have more of ionic character. All right. So let us move to the next question. We have three aqueous solutions of NaCl labeled as A, B, C with concentration 0.1 molar, 0.01 molar, and 0.001 molar. Respectively, the value of want-off factor for these solutions will be in the order. Now, if you follow NCERT, there is a chart given, right, in the solutions chapter, which clearly, gives these values that NaCl at where the concentration is 0.1 m, 0.01 m, and 0.001 m. This is NCERT theory only. There's a chart given. The value here is 1.87. The value increases, that is 1.94, and it further increases 1.97. And when it is, we can say, infinite dilution, or there is a complete dissociation, then the I value corresponds to 2, right? So as per this, IC will be most, followed by IB, and followed by IA. So A is the right answer. Okay, please follow NCERT book and just check this chart over there in the solutions chapter, class 12th, right? Okay, let us move to the next question. In Zeldar's method for estimation of nitrogen, CuSO4 acts as, now this is a fact-based question, CuSO4 acts as a catalyst. It acts as a catalytic agent. We know that Zeldar's method is used for the estimation of nitrogen via NH3, right? Okay. So organic compound, we know the principle, organic compound containing nitrogen, it reacts with H2SO4, give rise to ammonium sulfate. Right? And CuSO4 here acts as a catalyst. Let us move to the next question. The statement number 1 is potassium hydrogen phthalate is the primary standard for standardization of sodium hydroxide solution. So if you have visited your chemistry lab, yes, this is absolutely correct, right? Potassium hydrogen phthalate is a weak acid. It is a weak acid, and you know it is a base. So yes, it is used as a primary standard. The concentration is determined, right? And what is the reaction? We have potassium phthalate. When it reacts with NaOH, what do we get? We get something of this sort plus H2O. So this statement is absolutely correct. Now, and what is the type of reaction? It is an acid-base reaction. So phenolphthalein can be used as an indicator. Yes, phenolphthalein can be used as an indicator. So both these statements are correct. So let us see the options. First is the right answer. Both statement 1 and statement 2 are correct. I hope the question is clear to you. Let us move to the next question. Okay, match the following. List 1, it has reactions. List 2 has reagents, right? So let us see. Okay, if you see this one, quite simple. This is Clemmensen, the reagent for Clemmensen reduction, the reduction of carbonyl compounds to alkanes, right? So yes, the reduction of carbonyl compounds, this is a ketone and it is being reduced to alkane part. The CO group is reduced to CH2. So B goes with 2, so let us see. So A is eliminated, 4th is eliminated. A and 3 can be the answer. Let us see this, the first one. Here we have, this is your ester moiety. Ester moiety is getting reduced to CHO. So we know that there is a reagent diol H, right? So diol H selectively reduce, cyanides and esters to aldehyde. So A goes with 4 in second and third. Okay, so we need to check C. We have benzaldehyde getting reduced to, okay, the aldehyde getting reduced to OH. So what we can write here, okay, let us see the fourth one. Here this carbonyl group is reduced to OH, but the ester group is intact. So we know NaBH4, sodium borohydride, it's a mild reducing agent which reduces carbonyl compounds, aldehyde and ketones to, alcohol, but the acid part and the ester part, it remains intact. It doesn't reduce them. So D goes with 3. So we have got third as the answer. And this for C part, this upon reaction with the Grignard reagent followed by hydrolysis end up giving you alcohol, right? So we know that if we have formaldehyde, which upon treatment with Grignard reagent, it gives us primary alcohol. Other aldehydes gives us secondary alcohol, whereas ketone upon reaction with Grignard reagent followed by hydrolysis gives us 3-degree alcohol, right? So I hope the question is clear to you. Let us move to the next question. Choose the correct options for choose the correct option for free expansion of an ideal gas under adiabatic condition from the following. Under adiabatic condition and free expansion, just pick up these words. Free expansion means that P external is 0. If P external is 0, W is 0. Work done is 0, right? Adiabatic condition, that means no heat transfer, right? According to the first law of thermodynamics, delta U will be 0. Because it is Q plus W, and it is since it is we are taking an example of an ideal gas, taking into consideration an ideal gas. In ideal gas, we know that U is a function of temperature. So if delta U is 0, delta T is also 0. So going by that, fourth is the right answer. I hope the question is clear to you. Let us move to the next question. Again, the statement type questions. The NH2 group in aniline is ortho and para directing and a powerful activating group. Yes, it is a powerful activating group. Absolutely correct. Statement number 2, aniline does not undergo Friedel-Crafts reaction. Yes, aniline does not undergo Friedel-Crafts reaction. Why? Because there is a complex formation. Aniline acts as a base, AlCl3, we know it's a Lewis acid. So there is a complex formation of the salt. Right? So this type of salt, and because of the positive charge on N, it becomes a deactivating group. So yes, aniline does not undergo Friedel-Crafts reaction, right? Because of a complex formation. So this type of complex is formed. So statement number 1 is correct, but statement number 2 is incorrect. I hope the question is clear to you. Let us move to the next question. All right, section B, question number 1. Number of optical isomers possible for 2-chlorobutane. All right, 2-chlorobutane. Now, 2-chlorobutane has one chiral center. If there is one chiral center, so it will have a D form, it will have a L form. There exists an enantiomeric pair. So number of optical isomers is 2. Very simple, it's 2. There exists an enantiomeric pair corresponding to this chiral center. All right. Let us move to the next question. The potential for the given half cell at 298 Kelvin is, this is the half cell given. Okay, so according to the Nernst equation, we know that E cell is equal to E naught cell minus, they have given this at 298 Kelvin, we can write this to be 0.06 upon N. N involved is 2, number of electrons involved, and log of, we can write pressure of H2, right, divided by concentration of H plus raised to its stoichiometric coefficient. Now, E naught cell is, because we are taking into consideration the She, standard hydrogen electrode, that is 0, minus 0.06 by 2 log of pressure is 2 atm, and this is 1. Okay, so we can write it as this. So this is minus 0.06 by 2 into log 2 is 0.3, right? And what do we get? Upon solving, we get minus 0.009, right? 0.009 volt. But we are supposed to give the answer in this form. So it will be 10 to the power minus 2. So we can write it is minus 0.9 into 10 to the power minus 2 volt. And we can write approximately 1. So it is minus 1 into 10 to the power minus 2 volt. All right. I hope the question is clear to you. Let us move to the next question. The number of white colored salts among the following is salt analysis. Now let us eliminate the options that we already know. If you know about chromates, we know that all the chromates are white in color. Oh, sorry, all the chromates are yellow in color. Obviously, there is silver chromate, which is red in color, but most of the chromates, they are yellow in color. So barium chromate, yellow. Lead chromate, yellow. We have calcium oxalate. Calcium oxalate we see in group 5 analysis, barium, strontium, calcium. It is white in color. Regarding the sulfates, we know the sulfates are water soluble except strontium sulfate, there is lead sulfate, right? So strontium sulfate being white in color, lead sulfate is also white in color. Now test for iodide, PbI2, that's yellow in color. Test for bromide, AgBr, that is pale yellow. Right? Magnesium, ammonium phosphate, we see in group 6 analysis, group 6 estimation of Mg2 plus, right? So this is again white in color. Test for Mg2 plus in group 6. Then we have this complex. This is the complex we see during the test of acetate ion, right? And it is red color. It is of red color. So, and manganese hydroxide, it is also white in color. So based upon salt hydrolysis, let us see how many white colored salts do we have? 1, 2, 3, 4, and 5. So the answer is 5. I hope this is clear to you. Let us move to the next question. The ratio of 14C upon 12C in a piece of wood is 1/8 part that of atmosphere. If half-life of 14C is 5730 years, then the age of wood sample is, okay, I'll tell you the two ways to do it. One is very simple. 1/8 means that it needs 1/2 to the power 3. That means it needs how many half-lives? 3 half-lives. So 3 into, and the half-life is 5730. So one way is 5730. One way is you can easily write this. The other way is that we know that lambda is equal to, or we can write the age of the sample is equal to, 1 upon lambda into ln of this ratio of C14 to C12 in atmosphere divided by the ratio of 14C to 12C in the wood, right? So what do we get? This is T is equal to 1 upon lambda. I can write 1 upon ln of 2, right? We can write ln of 2 upon T half. So I'm writing T half over here. And this is ln of, now we are having the ratio 14C upon 12C in a piece of wood is 1/8. So I can write it as ln of 8. This is ln of 2 into T is equal to T half into ln of 8. And from this also we are getting 3 into 5730, which is 17190 years, right? This is 17190 years. So the answer is 17190 years. I hope this is clear. Okay, so let us move to the next question. The number of molecules, ions having trigonal bipyramidal shape. Trigonal bipyramidal shape, that is TBP. So let us see. PF5, yes, it is TBP, trigonal bipyramidal. And we have PCl5, yes, trigonal bipyramidal. BRF5 is square pyramidal. This is square pyramidal. PTCl4 is square planar because it is a member of, we know that member from the 4D and 5D, they always form, as the coordination number 4, they always form the square planar complex. BF3 is trigonal planar. And FeCO5 is also TBP, right? And what is the hybridization of F? That is DsP3. So how many trigonal bipyramidal shape molecules do we have? 1, 2, and 3. So the answer is 3. I hope the question is clear to you. Let us move to the next question. Total number of deactivating groups. Okay, deactivating groups they are asking. All right, so this is your aster moiety. It is -M group, deactivating group. Here we have the lone pair of electrons. So it is your +M group. We have the electrons. It is your +M group. Cyanide is your -M group. And OCS3, so because of the lone pair of electrons, this is your +M group. So how many deactivating groups do we have? We have 1 and 2. So the answer is 2. Simple question. Okay, I hope the question is clear to you. Let us move to the next question. Lowest oxidation number of an atom in a compound A2B is -2. The number of an electron in its valence shell is, okay, so we have this type of molecule AB2. So AB2 means that we have 2A plus and B2 minus. So it is saying that lowest oxidation number of an atom in a compound is -2. All right. So the number of an electron in its valence shell. So basically they are asking you the number of electrons in the valence shell of this B. Okay. Now after taking up these 2 electrons, the octet of B is complete. So how many electrons were there in the valence shell? So there are 6 electrons in the valence shell of B, because after taking up these 2 electrons, it completes its octet. So the number of an electron in its valence shell is 6. All right. So I hope the question is clear to you. Let us move to the next question. Among the following oxides of p block elements, number of oxides having amphoteric nature. So let us see the nature of all these oxides. Cl2O7, we know it's acidic in nature, right? CO is neutral. PbO2 is amphoteric, right? N2O is neutral. Nitrous oxide is neutral. NO, nitric oxide is neutral. Alumina, that's your amphoteric. SiO2 is acidic in nature. N2O5 is acidic in nature. And we know that oxides of tin and lead, they are amphoteric. So this is amphoteric in nature. So how many amphoteric oxides do we have? 1, 2, and 3. So the answer is 3. All right. I hope the question is clear to you. Let us move to the next question. Consider the following reaction. This is the reaction. If 72 millimole of PbCl2 is mixed with 50 millimole of ammonium phosphate, then amount of lead phosphate formed is dash. All right. So let us find the LR, that is limiting reagent. So for that, what we can do is 72 millimoles. So we can write 72 upon 3, and this is 50. So 50 upon 2. So what do we get? This is 24. This is 25. So PbCl2 is your LR, right? PbCl2 is your LR. So 3 moles of PbCl2 is producing 1 mole of lead phosphate, right? So 72 millimoles will produce 72 upon 3, that is 24 millimole of product or lead phosphate. So the answer to this question is 24 millimole. I hope the question is clear to you. Let us move to the next question. So let us see the last question for today. Ka for acetic acid is 1.8 into 10 to the power minus 5, and Kb for ammonium hydroxide is this. Acetic acid being a weak acid and ammonium hydroxide being a weak base. So we are supposed to find out the pH of this salt. So this is a question from salt hydrolysis of a salt of weak acid and weak base. So we know that pH can be found out by 7 plus half into pKa minus pKb, but both pKa and pKb are equal, right? So what is the answer? The answer is 7. So the pH of ammonium acetate solution is 7. I hope the question is clear to you. Thank you so much.